math enthusiast! How are you? For this video, I will teach you how to graph linear inequalities into variables in a very easy steps. Are you ready? Then let's get started. But before diving into our main topic, let us familiarize and recall first how linear inequality differs from linear equation into variables. Now, let us discuss their similarities first. For an illustration, we have an example here for linear equation, which is 2x plus y equals 0. On the other hand, we also have here an example of linear inequality, which is 2x minus 3y greater than or equal to 11. Now, by just observing the two equations and inequality, it is obvious that they are similar in terms of mathematical sentences. Yes, it is mathematical sentences. Now, let's move on to their differences. What do you think are the differences? Well, let's find it out. First, we have signs. For linear equation, as we have seen in its example, we have an equal sign. While on the linear inequality, we have the following signs. It could be less than or equal, or greater than, and greater than or equal. Now, another differences we had is their solutions. Yes, it's their solutions. In linear equation, we have solutions like it could be that there is no solution, or one solution, or it could also be that it has many solutions. But for the linear inequality, our solution is the set of solutions containing values that satisfies the inequality and make the statement true. Now this time I will going to introduce to you to linear inequalities into variables before I will proceed to discuss the steps of graphing linear inequalities into variables. Now, what is this all about? Well, it is an equality that can be written in one of the following forms: ax plus by less than c, ax plus by less than or equal to c, or ax plus by greater than c, or ax plus by greater than or equal to c, where a, b, and c are real numbers and a and b are both not equal to 0. How to graph linear inequalities into variables in a very simple steps. But before that, we have 5 points that we need to understand and consider in constructing the graph of linear inequalities. First, we should know what is its graph. Be reminded that its graph is a set of points that represents all solutions to the inequality. Remember that it must contain not only one point but a set of points. Second is to be knowledgeable of its solution. Take note that each solution is an ordered pairs which make the inequality true and satisfy its statements. Third, be familiarized of its graph. In constructing it, be reminded that if the given inequality uses less than or greater than, use broken line. But if the given inequality uses less than or equal to and greater than or equal to, you will use the solid line. Next is the test of origin. This is an important procedure since it is the basis of shading the region that is part of the solution. For doing this, Just substitute 0, 0 to its inequality. If the origin make the inequality true, then you will shade the half plane containing the origin. But if not, then you will shade the half plane does not contain the origin. Lastly, we need to know the different methods in solving linear inequality that will help us construct its graph. So we have three methods that we will use or that we can use. First, we can use the x and y intercept. But if it is not easy for you, then you can also use the 2 points. And still it doesn't work for you, then you can also use the slope-intercept form. For a clearer visualization of the graph of the linear inequality in two variables, I will discuss to you its parts. Now, as you can see, its graph is divided into two planes, the shaded and the unshaded region. The shaded part and the solid line represents the solution set that satisfies the inequality and makes the statement true, while the unshaded region and the broken line indicates that it is not part of the solution. Now, it's time for us to go through with the examples so that you will understand and learn how to graph linear inequalities in two variables in an easy way and easy steps. So, as part of the demonstration, I will use the three methods aforementioned earlier. So, we have here our first example. Graph the inequality 3x plus 2y less than 6 using x and y intercepts. So for graphing the linear inequalities into variables, in this method, we first need to find the x and y intercepts, of course. So now let us find the value of our x-intercepts. Let us rewrite the inequality 3x plus 2y less than 6 into an equation. So we have 3x plus 2y equals 6. Next is we will substitute 0 as the value of y since we were going to find the value of x or the x-intercept. So by doing multiplicative inverse, we will multiply both sides with 1/3. So we have here the answer x is equal to 2, or our x-intercept is 0 to 0. For the y-intercept, it is the same procedure. We will rewrite the inequality into an equation. And then, for this time, we will substitute 0 as the value of x since we were going to find the value of y. Again, by doing the multiplicative inverse property, we will multiply both sides with 1/2. So we arrived the value of y, which is 3. Now we have the x-intercept, which is 2, 0, and y-intercept of 0, 3. After we get the value of x and y-intercept, now let's move on to the next step, which is plotting the x and y-intercepts into the Cartesian plane. So from the inequality, we transform it into an equation, and from that equation, we were able to get the x-intercept, which is 2, 0, and y-intercept 0, 3. So we are now ready to plot it on the Cartesian plane. The x-intercept we have here, we can plot it here, and here is for the y-intercept. Now we will connect the 2 points by using the broken line, since the given inequality uses less than. Third and the last step is to test the origin if it is part of the solution set. We can do this by substituting 0, 0 into the inequality. So from this inequality, we will substitute the 0, 0 or the value of the origin, which is the x and y values respectively. So it will become 0 is less than 6, which is the statement is true. So since the origin makes the statement true, then we will shade the half plane containing the origin. So it is under the broken line. So here it is. So it's the solution and the graph of the first problem. So easy, right? Okay, let us learn more by having another example. Now this time we will solve the inequality by using 2 points. So we had here a given problem. Graph the inequality x plus 2y greater than 7. Now in this method, the first thing we do is to set values for our x and y. Or if you will use the abscissa, you will provide 2 values for x. And if you will use the ordinate only, you will also provide 2 values for y. Now in my example, I set the values for both x and y that I will use to evaluate in the equation so that I can have its ordered pairs. So we use here x is equal to 1 and y is equal to 2. So first, let us find the value of y when x is equal to 1. So from inequality, we transform it into an equation and it becomes x plus 2y equals 7. After that, we will substitute the value of x. So it will become 1 plus 2y equals 7. And we will apply the additive inverse property. So we will add both sides with -1. So it will become 2y equals 6. And from that, we will apply the multiplicative inverse property that we will multiply the equation by 1/2. So it will become y equals 3. Therefore, if x is equal to 1, then we will have a value of y which is 3. So we have a point 1, 3. Now let's move on to another value. So we will find the value of x when y is equal to 2. Now again, let us rewrite the inequality into an equation. So it will become x plus 2y equals 7. And then substitute the value of y. Then we will evaluate it, making x plus 4 equals 7. And again, let us apply the additive inverse property. So we will add both sides with -4. So from that, we arrive x is equals to 3. So therefore, if y is equal to 2, then our x value is 3. So we have now our ordered pair, 3, 2. Since we already have the 2 points, we are now ready for our second step, which is plotting the 2 points in the Cartesian plane. So from the inequality, we transform it into an equation. So from that equation, we're able to get our 2 points, 1, 3, and 3, 2. So it's now time to plot it into our Cartesian plane. So for point 1, 3, so we have here, and for 3, 2 is here. Yes, now we will connect the 2 points by using, yes, we will use the broken line. It is because the given inequality uses greater than. Moving on to the next step is the testing of the origin. Same procedure of what we did in the first example. So we will substitute the origin to the inequality. So we have this, and will become 0 is greater than 7, which means that the statement is, yes, it is false. So since the statement is false, upon substituting the value of the origin, so this means that in shading the region, we will not shade the part where the origin is in. So basically, we will shade above the broken line, which represents the solution set of the inequality x plus 2y greater than 7. So it's easy, very easy, right? So now we are here in our last example using the last method. So we have here a given problem, which is graph the inequality 3x plus 2y less than or equal to 6 using slope-intercept form. Now for this method, the first thing to do is of course to find its slope and y-intercept. So to find it, we should rewrite the inequality into an equation. So from 3x plus 2y less than or equal to 6, it will become 3x plus 2y equals 6. So next, we need to identify the values of a, b, and c. So in identifying these, we just refer to the inequality form, which is ax plus by less than or equal to c, so that it will be easy for us to identify it. So we had here already the values of a, which is equal to 3, b is equal to 2, and c is equal to 6. Now this time, let us recall the slope-intercept form, which is y is equal to mx plus b, where m is equal to its slope and b is equal to its y-intercept. Now this intercept form, we can also rewrite this like this. Y is equal to negative a over bx plus c over b, so that we can use the value of a, b, and c by substituting it. So let's substitute the value. So we have y is equal to negative 3 halves x plus 6 over 2. So we will evaluate it further. So it will become y is equal to negative 3 over 2x plus 3. Now, we can now identify or determine our slope, which is m is equal to negative 3 halves. And for our y-intercept, we will have b, which is equal to 3, or we have a point 0, 3. Proceeding to our next step, which is plotting the slope and y-intercept in the Cartesian plane. So again, we have our given inequality, which is 3x plus 2y less than or equal to 6, and from that we transform it into an equation, and from that equation we're able to determine its slope, which is equal to negative 3 halves, and our y-intercept, which is 0, 3. Now we are ready to plot it on the Cartesian plane. So first, let us plot the slope by using its basic concept, which is rise over run. So we have here 3 units rise, which is basically here, and 2 units for run, which is here also. And after that, we also have to plot the y-intercept, which is here. So they have just the same value, location with the slope that we have, which is 3 units from the origin. Now it's time for us to connect the 2 points. So yes, we will use the solid line. It is because the given inequality uses less than or equal. And as we have observed, the arrow rise up on the left side of the origin. It is because our slope is negative. Now we are already in our last step, which is the testing of the origin. From this inequality, 3x plus 2y less than or equal to 6, we will going to test the origin by substituting its value if it will make the statement true or false. So let us substitute it. And now we will arrive to 0 is less than or equal to 6, which is, yes, it is a true statement. So in our graph, we will shade the region wherein the origin is part of it. So basically, it is below the solid line. So that is the graph of the inequality 3x plus 2y less than or equal to 6. There you have it all, math enthusiasts. The very easy steps of graphing linear inequalities into variables. I hope you have learned a lot on this video. Always remember, sipag plus tiyaga equals madali. Goodbye!